Hello, good day. So this is your teacher Nell. We're going to review your Math 9. Let's start. Which of the following is a quadratic equation? In order to find if the following equation is a quadratic, their degree must be 2. When we talk about degree, that is the highest exponent. So let's look for the highest exponent for each item. In number 1, the highest exponent is 2. This is an example of quadratic equation. So checked. Number 3, the highest exponent is also 2. This is also a quadratic equation. In number 3, highest exponent is also 2. This is also a quadratic equation. So that means all of the equations are quadratic equation. Which of the following quadratic equations can be readily solved by extracting square roots? So our formula is x squared is equal to a, wherein a is constant and your x squared is your quadratic term. So here we have no linear term. That is the only clue that we need to look for. Okay, if equation has no linear term, then it can be solved by extracting square roots. In number 1, we have the presence of linear term, which is 4x, so that means it cannot be solved by extracting square roots. Same goes with number 2 because there is a linear term of 4x. In number 3, 0 linear term, so that means it can be solved by extracting square roots. So to answer, the only equations that can be really solved by extracting square root is the number 3. That is x squared minus 25 is equal to 0. Determine a, b, and c in the equation 3x plus 7 plus 4x squared is equal to 4x minus x squared plus 2. Remember that in order to find the numerical coefficients of your quadratic equation a, b, and c, we need to see to it that your equation is in its standard form. That is in the form of ax squared plus bx plus c is equal to 0. So on the given right part of your equation, there is a presence of expression 4x minus x squared plus 2. All we have to do is to transpose them. Okay, we will transpose them. So first is the quadratic term. The negative x squared will be transposed, becoming positive. 4x squared plus x squared is 5x squared. Then the linear term 4x will be transposed. Equation becomes 3x minus 4x, that is negative x. And your constant 2 transposed, 7 minus 2 is 5. Then rearrange the order. We have 5x squared minus x plus 5. We can now find your a, which is 5, b, negative 1, and c, which is 5. These are your numerical coefficients. What are the roots of the quadratic equation 9x squared minus 10 is equal to 39? Again, we have 4 ways to solve for the quadratic equation. First is extracting square roots, second factoring, third completing the squares, fourth quadratic formula. So here, based on our given equation, we have no linear term. So among the ways that we have, extracting square roots can be easily solved the quadratic equation. So first, transpose negative 10. Equations become 9x squared is equal to 49. Divide by 9 to get 49 over 9. Get the square root. We have positive negative square root of 49 over 9, or that is positive negative 7/3. These are the roots of your quadratic equation. What is the factored form of the quadratic equation x squared plus 2x minus 48 is equal to 0? So first, we will use your last term, which is constant, that is negative 48. Then your linear term is positive 2. So that means one of the factors of negative 48 must be positive, which is a higher integer. So these are the possible factors of negative 48. Then we will use your linear term, the 2x. So all we have to do is to add the factors of negative 48. Then look for the sums, which is 2, and that is the factor of your equation. So add, then we get positive 2. So that means the factor form of the quadratic equation is x plus 8 times x minus 6 is equal to 0. What is the possible quadratic equation whose roots are 3 and 5? So here, roots are 3 and 5. X is equal to 3 and x is equal to 5. We will reverse the process. Transposed to get x minus 3 is equal to 0 and x minus 5 is equal to 0. Then, zero product property, we have x minus 3 times x minus 5 is equal to 0. FOIL method, the first and first, outer and outer, inner and inner, then last by last, to obtain x squared minus 5x minus 3x plus 15 is equal to 0. Simplify further, combine like terms, negative 5 minus 3 is negative 8, and this is your quadratic equation. X squared minus 8x plus 15 is equal to 0. The roots of the equation 3x squared plus x minus 4 is equal to 0 are m and n. What is the value of m squared plus n squared? Before getting the value of m squared plus n squared, we need to find the values of your m and m, which are roots of your equations. So we can solve this by factoring. So factors of 3x squared plus x minus 4 are 3x plus 4 times the quantity of x minus 1. Apply zero product property, separate, then transposed to get this. Divide x by 3. Divide 3x is equal to negative 4 by 3 both sides to obtain the value of x. So therefore your m is negative 4/3 and your n is 1. Then m squared plus n squared is equal to the square root of your m plus the square root of your n to get 16 over 9 plus 1, or simply 25 over 9 using your calculator. This is now the value of m squared plus n squared. The length of a rectangular garden is 5 meters longer than its width, and the area is 40 meters squared. What is the length of the area? So the following givens are length 5 meters plus width and area, which is 40 meters squared. We all know that the area of rectangle is L times width. Substitution, A becomes 14, then L becomes 5 plus W. Distribute to get W squared plus 5W. Then transpose 14 to the right side to combine all terms. So we have W squared plus 5W minus 14 is equal to 0. Then apply factoring. Factors are W plus 7 times W minus 2. Zero product property. Isolate 7. Isolate negative 2 to get negative 7 and 2. We have the roots here. And these are possible value for the width, negative 7 and 2, but we cannot have measurement of negative, so we will reject negative 7. We will get only 2. Looking back to the question, what is the length of the garden? That is simply 5 plus your width, which is 2. That is 7, and 7 is the length of the garden. What are the roots of the quadratic equation x squared plus 10x minus 56 is equal to 0? Same process in factoring. Look for the possible factors of negative 56. So our midterm or our linear term is positive 10. So that means the second or the higher integer of the factors of negative 56 must be positive. So these are the possible values or factors for negative 56. Then use the linear term, which is 10x. Simply add the factors of negative 56. And here is your positive 10. So that means the roots are 14 and negative 4. And that is the answer. how are the roots of ax squared plus bx plus c is equal to 0 and cx squared plus bx plus a is equal to 0 related? Now we will look for the sum of the two equations and product of the equations using sum of the roots and the product of the roots. So for the sum of the roots, we have negative linear term minus divide rather by the coefficient of your quadratic term. So sum is negative b over a. For the product, we have constant over your first numerical coefficient of your quadratic term, that is a. So product is c over a. Second equation, sum is negative b over c, while the product is a over c. Then we will compare the sums. So sums are not related, but product are multiplicative inverses, and this is the answer. Product, or rather the roots of ax squared plus bx plus c is equal to 0 and cx squared plus bx plus a is equal to 0 are multiplicative inverses. To solve the equation x squared minus 10x is equal to negative 15 by completing the square, what is the next step to continue the solution? If we can still recall the steps of finding the solution of quadratic equation using completing the squares, first step is to isolate the constant. So it is given. Then the second step is to add both sides by the square root of b over 2a, or that is root 25 over 4. And this is the answer. Then here, given equation, what is the number must be added to both sides to complete the square? We will use the formula b over 2a squared, where b is negative 4/3 and your a is 1. Simplify further, that is negative 4/3 over 2. Keep, change, then flip. So 2 becomes 1/2. Divide becomes multiply, and then keep your negative 4/3. So 4 times 1 over 3 times 2. So 4 here and 2 can be factored out. So 4 is 2 now, and 2 is 1. So negative 2 times 1 is negative 2, and 3 times 1 is 3, and the square root of this is 4 over 9. And this is the number that must be added to both sides to complete the square. The length of the front lawn of a house is 12 meters more than its width. If the area of the lawn is less than 50 meters squared, what could be the length of the lawn? Given length 12 meters plus width, and we have the area of 50 meters. So area is equal to length times the width. Substitution, area is 50, length is 12 plus w. Distribute 12w plus w squared. Rearrange the order or the terms. W squared plus 12w minus 50 is equal to 0. Using the quadratic formula, because it cannot be easily factored out using factoring nor using extracting square root, so we will use your quadratic formula. So your b here is 12, your a is 1, and your c is negative 50. Simplify. 12 squared is 144. Negative 4 times 1 times negative 50 is positive 200. Add square root of 344. 344 is not a perfect square, so that means our roots are two real and irrational numbers. So simplify further using your calculator. It will give us the roots of 3.27 and negative 15.27. And this is your answer for the width, that is 3.27. The length rather, which is 3.27. Which is the discriminant of the quadratic equation 2x squared minus 4 is equal to 5x. So to find the discriminant, formula is b squared minus 4ac, but we need to check whether your equation is in its standard. So we will change first. So 5x will be transposed to become negative 5x. A is 2, B is negative 5, and C is positive 4. Substitution, discriminant is equal to negative b squared minus 4 times 2 times negative 4. Simplify, square root of 25, or rather negative 5 is 25. Negative 4 times 2 times negative 4 is positive 32. Then we get 57. And we all know 57 is not a perfect square, therefore the roots are 2 real and irrational. And the discriminant is 57. What is the solution set of the quadratic equation 5x squared minus 3x minus 2 is equal to 0? So here A is 5, B is negative 3, C is negative 2. Using your quadratic formula, substitute, then simplify, double becomes positive. Square root of negative 3 is 9, negative 4 times 5 times 2, negative is positive 40. Then we have square root of 49. Then separate, therefore your x is 10 over 10, or that is 1, and negative 4 over 10, or that is negative 2/5. And this is your final answer. What are the roots of the quadratic equation x squared minus x plus 1 is equal to 0? So this equation cannot be solved by extracting square roots, nor completing the square, nor factoring. So we will use your quadratic formula, wherein A is 1, B is negative 1, and C is 1. This is your formula. Substitute, double becomes positive. Square of negative 1 is 1. Negative 4 times 1 times 1 is negative 4. 1 minus 4 is negative 3. And square root of negative 3 is an imaginary. We will take the imaginary part of square root of negative 3. That is square root of negative 1, or simply I. Therefore, the roots are 1 plus minus I square root of 3 all over 2. The values of A, B, and C in the equation 2x squared minus 7x is equal to 3 are correctly substituted in which quadratic formula? So here B is negative 7. Upon looking, or by mere inspection, among the choices that we have, so we all know that the formula of quadratic formula is x is equal to negative b. So what is negative b? Negative 7, and negative is positive, so the only answer here is number 2. What is the most appropriate method to use in solving w squared plus 3w minus 1 is equal to 0? That is by quadratic formula. One of the roots of the quadratic equation 2x squared minus 13x plus 20 is equal to 0 is 4. What is the other root? So again, x is equal to 4. That means x minus 4 is equal to 0. Now, what is the other root? The other root is simply here, you divide 20 by negative 4, that is positive 5. And then divide 2x squared by x to get x, and the other factor is 2x minus 5. Okay, so we will take negative 5 for the factors of negative 4 and negative 5. Since 20 is positive, the middle term is negative. Adding negatives result to negative. Hence, other factor is 2x minus 5. Which quadratic equation whose sum and product of its roots are 2 and 3 negative respectively? This is the formula. Simply substitute the value of your sum, which is 2, and product of negative 3. Then positive negative gives us negative, and this is the equation x squared minus 2x minus 3 is equal to 0. One of the roots of a quadratic equation is 2 minus square root of 5 all over 3. What is the quadratic equation? We all know that the roots has positive and negative counterparts. So if given is 2 minus square root of 5 all over 3, the other root must be 2 plus the square root of 5 all over 3. Okay, equate 0. Equate all the roots by 0, then multiply both sides by 3 to obtain 3x minus 2 plus square root of 5. First root, Second root is 3x minus 2 minus minus square root of 5 rather is equal to 0. Okay, distribute to get the following. Then and last to get the following terms. Then combine like terms. Negative 6x minus 6x is negative 12x. Negative 3 square root of 5x plus 3 square root of 5x will be eliminated because that is 0. Then 2 square root of 5 minus 2 square root of 5 is also 0. Constant is negative 5 plus 4, that is negative 1. So therefore, quadratic equation of your given is 9x squared minus 12x minus 1 is equal to 0. Which best describes the nature of the roots of quadratic equation x squared plus 7x minus 18 is equal to 0. So we will look for the discriminant. B is 7, A is 1, and C is negative 18. Simplify. Square root of 7 is 49. Negative 4 times 1 is negative 4 times negative 18, that is positive 72. Combine. Constant. Discriminant is 121. 121 is a perfect square, therefore the roots are 2 real and irrational roots. That is the end of the slide. Thank you and have a nice day. See you on the next quarter.